side of that
classical
group?
Greeks knew the Earth was a sphere.
No, that's a lie.
False.
Okay, prove it.
You prove it.
Yeah, you
So
still
fast.
improve the air pressure thing.
I mean, so fast.
How would they know it's a
Clock
sphere?
even is charged up with
No,
the battery.
You guys hear
How
me?
would they know it's a? How would the ancient Greeks know it's a
I hear you,
sphere?
Tebow.
What could they actually do?
They didn't believe it was a sphere.
Stellar navigation was one thing.
Oh, they navigated the stars?
Okay, so that doesn't tell them that the
Sun-
Earth's a sphere. Try again.
He thinks Greeks had
The
spaceships.
sunrise and
Started there.
sunset and the
That
phases
doesn't
of the
tell
moon.
the Earth is a sphere either. So try again.
I have yet to see someone explain.
You haven't named
how
anything
phases
about
of the
the
moon
Earth.
work
You
on a
said
flat
something
Earth.
about the sun. You said something about the stars. You said something about everything but the Earth. I said, how do they know the Earth is a sphere?
That is how.
Oh, so they don't
Because
know.
there are-
Congratulations.
Yes, they do. Because there are
No,
things
because
that
what
we
you're talking
observe
about,
that
you
only
listen,
work if
listen.
Earth is a sphere.
Look, bro. No, you're claiming that, but that's not true.
And you
So, it's real-
explain lunar
I don't need to
phases
explain
on a flat
anything.
Earth.
You
Yes,
need to
you do.
demonstrate.
You
need
are
to
making
demonstrate
a claim
that it's
lunar phases work on a flat Earth.
Grummet.
Okay,
Can you
Grummet.
explain
so again,
how?
once again, the moon. We're not talking about the moon. We're talking about the Earth. You said they know that the Earth is a globe. Okay? Everything you're talking about would be an inference, and inferences aren't knowledge. So I can look around my neighborhood and see all brick houses and infer that my house may also be made of brick. But that doesn't, I don't know my house is
Seeing
made of brick
the
until I look
moon
at my,
go through
shut
phases
up,
and
shut
saying,
up,
"This
dude, let me
doesn't work
finish
on
the
flat
fucking
Earth," isn't the
sentence,
same
dude.
as going
So,
all the
dude,
Let
just
him.
go on fucking mute, bro. Really simple. Let me finish my fucking sentence. Okay? You can look at all your goddamn neighbor's house and they're made of brick, but you don't know if your house is made of brick until you look at it. So, how do they know the Earth is a sphere? Go
by
ahead, dude.
observing things that are impossible on a flat Earth, as
Okay,
I've
you
said.
don't know if they're impossible on a flat Earth. You haven't demonstrated they're impossible on a flat Earth. You just believe that.
They have been demonstrated as being impossible on a flat Earth.
By who?
Okay, show
Name
us.
one scientific experiment. Please.
Demonstrate that they are. That's
Mickelson-
the
No,
thing I'm
that's not how
asking.
it works, dude.
There's a
So
burden
there's
of
things
proof
like
that
called
you're creating.
exclusionary. There's called exclusionary proofs, right? So Fermat's principle, Fermat's last theorem. A squared plus B squared equals C squared. It is a limit. So hold on, dude. No,
making a claim that it is possible on a flat Earth. That is your indirect claim.
That is my
I think
indirect
you'd
claim.
be smarter if you listened to people when they were educating you.
Yeah, he can't. He's fucking locked in. The fact remains is the Greeks didn't know fucking anything. And nothing they can observe about the heavens will tell them what the shape of the earth is because it's inferential.
Okay,
My
so
This is
neighbor
just a
has-
matter of logic, dude.
how do
period.
you know? How do you know the Earth is flat other than it looks flat?
Okay,
All right,
measurement.
this is how you sound. Can I have a minute,
Such
please?
as what
Measure-
measurement?
Measure. Oddly enough, you can measure the surface of the earth with a laser.
Indio, can I have a...
Hold on. He asked the question. So you shoot a laser, and if the Earth is a globe and the surface of the Earth is curving, that means as you go along the laser, the surface of the Earth should get farther and farther away from the laser as an exponential function. So such as 40 kilometers, the laser should be 420 feet or 400. Who's interrupting me?
Yeah, it's
Yeah, I don't think so, dude. So, the laser at 40 kilometers away should be 400 or should be 127 meters off the surface of the Earth. And when we do this test, that's not the case. It's 1.5 meters off the surface of the Earth, the same height it started as. That means the laser and the surface of the Earth are in parallel. This is measuring the Earth. And this is just one of many, many measurements of the surface of the Earth.
I gonna
Go
get
ahead,
the
Iron.
whole argument of light
forgot
doesn't
what I was
bend
gonna
here
say, sorry.
when I explain to you how
Doesn't
that
bend.
works?
Look, bro, this is off by the prediction by 2 orders of magnitude. You can't get light to bend that much. Okay, unless you have like a fucking 170-degree temperature gradient, which is unphysical.
You probably have like a 10 to 12 degree gradient on the surface of water that you're shining a laser across. You might get some refraction or diffraction, or
Well, if you apply
let's
standard
see.
refraction at this distance, you'll move the laser down 5 meters. But you need to
Right,
move
but
it down another 100. Hold on, you need to move it down another 122 meters. So where are you
no,
getting
but you'd
that from?
expect a difference of like 10% maximum.
No, that's not how it goes, dude.
No, for
It's
atmospheric.
not a linear relationship.
No, I'm saying if I were to do this experiment myself, I would expect a 6 to 10% degree of variability based on atmospheric conditions, or the temperature of the water versus the air right above the water versus the
I
temperature of the
mean,
air 10 feet
that's
above the water.
that's
There could be
fantastic.
some shit to there. I wouldn't expect it to be exact, but I would expect it to be within one.
How are you going to measure that?
Well,
Not 10.
that's all fantastic because the results here are 1,000% off.
Right, my point exactly.
2
But you
orders of
could not
magnitude.
ascribe that to atmospheric refraction or anything like that. It has to be because it's so far off that it cannot be, oh, the wind blew.
Well, I mean, it would be very odd that not only did, because they actually did these tests 3 weeks apart, so it would be very, very fucking odd. And they had meteorological stations that not only did they not measure the frickin' weather condition with 2 meteorological stations at the endpoints 3 weeks apart, and they
Can you
had the
send me-
identical magical weather conditions 3 weeks apart that let
Indo,
them
can you send me
frickin'
a
be
link to
see
this
a globe.
experiment?
Yeah. I'll post in the chat.
I'm on your side.
Well, I mean, it'd be very fucking odd they did it again 3 weeks later.
I think the ideal version would be if the temperature of the water and the temperature of the air were the same magically on one day. That's the day you take the measurement. That's most clear. So you don't have that distortion of the temperature difference above the surface of the water across a lake or something like that. I think that's the
That's
ideal.
just one of many. I mean, we got Salt Lake one. We got frickin' Salt Lake on the land, on the water. Like every way you can frickin' slice it, it's been done.
I agree. But some people still can't see it.
They don't want to see it.
They want to argue with you.
The Salt Lake one that DJ shows all the time is pretty cuckoo. You can see 21 miles to the other shoreline. And at that night, they went and they shot the laser across the same distance, 21 kilometers. And not only do you see the laser, you see the reflection of the laser off the water, which, if
Oh shit!
that's impossible.
Indio is bouncing the laser back to the original observer. Is that the way to prove it even more?
No.
Nobody saw it
Check
yet?
it out. If the laser's supposed to be behind the curve, right, on the other side of the curve, how could you ever see the reflection of the laser off the water?
They're always trying to hit a target across.
Think
the
about
water.
it. Hold on, dude. Think about what I'm saying for a second.
Man.
You got a hump, a hill. How can you just see the reflection off the laser when the only place the laser can bounce off is the other side of the hill?
You can't.
Yeah, you can't. But we do.
I want
So
one of those lasers.
would it be a good proof if you shined a laser across the lake and had it bounce back across the same lake to you?
I mean, they did a triple mirror flash at the Salton Sea, where they made basically a giant frickin' triangle, right? So one mirror operator could see 2 other mirrors at the same time. In each point of that triangle, each person could see the other 2 mirrors, which are also see like 128 feet under the curve of the Earth.
So
That reminds me of the Michelson-Morley experiment a little bit.
just wondering, did they have multiple vertical arrays recording temperature along the entire path of the laser.
Why would they need to do that, dude?
What do you mean? Why would they need to do that?
Yeah, I'm asking why
Because
you're asking me.
refraction.
Because that's a red
refraction
herring.
isn't-
So I guess
No, it's
the
not.
military can't use line of sight anymore.
No, it's
You
not, because
understand that you
refraction
need
isn't
to move the
something where it's,
laser.
this big area has this refraction.
Yeah,
It
but you need to.
changes for
Yeah, that's
every.
a cool story, but no one's ever demonstrated that this type of refraction actually exists. Okay.
Hypothetically,
can see.
if there
Okay,
was
because I already told you that the drop was supposed to be 127 meters. Now, if you use standard refraction calculation, that only moves the laser down 5 meters. So now you have 122 meters to make up. So you would
And
need some crazy abnormal day, not only just once, and not at just one distance, at 7 different distances, with 3 tests done 1 week, and 2 more tests done 3 weeks later. In the same crazy refractive condition, a 20 times deflection refraction condition that makes the Earth looks like it has a radius of 65,000 miles. That would have to exist.
yeah, he'll cherry
By
pick
random, 2 weeks apart, and it didn't show up on their meteorological station somehow.
He will cherry pick an example that says, "Oh, look, the math matches up for me right now."
No, I'm not cherry
but
picking.
he
It's
ignored
people
the
that
other
know what the
200
hell
The thing
they're
is, you
doing.
can't just say the
measurements
magic
prior.
word refraction. You need to justify how it even applies. You need to actually justify using it.
Refraction applies to everything that you do in the
Oh,
atmosphere.
yeah, that's your claim, dude. That's not a justification.
So
Doesn't
refraction
demonstrate your
applies
knowledge.
If
when
I
I
drop
want
a
to fly a
bowling
plane.
ball off a cliff, and I say, "Hey, dude, that's fell at 10 meters per second squared," and you say refraction, and I go,
Why are
"Dude, you
you
need to
comparing-
justify why refraction affects a bowling ball," and you're like, "Refraction applies to everything."
Refraction applies to light, not solid objects.
So you understand now why your
Okay,
observation
why does it apply to
based on
light in this case?
Because you're over water.
Oh, okay, so water causes
The re-
refraction?
Yeah, there's a higher refractive index over water.
Okay,
Why?
that's not how it works. You don't
Hold
know
on,
what
hold
you're
on.
talking
Nothing to do
about.
with
Asking why.
temperature
Asking
variations.
why.
Yeah.
Yeah, that's what it is. It's the variation because the water is there.
Because the water's there, that makes
So
the light.
Yeah,
there's-
you
so let's get
realize
this
there's
straight.
there's a difference in
Grumman,
temperature
slow down.
between
You're going
the
to
air
fry your
and the
brains.
water.
Grumman,
Yeah, we know
silence.
they measured.
Bro.
So let me get this straight. When we go to the salt flats, there's 0 miraging effects because there's 0 water.
No. I said
Oh,
there's
so it's not water of this cause and effect relationship.
Boom.
I said there is a more.
Look, brother.
By what
Okay.
differential?
You would need the water in the air to have a 70-degree temperature difference.
What do you think that the temperature difference between the air in the atmosphere and water that's like
Hold up.
in the Gulf of
time
Mexico?
That's what causes. So what
Temperature
causes?
between the
What
air and the atmosphere? Time out.
All right, are
time
you
out.
cocked or something, dude? You drinking, brother?
The temperature difference between the
Yeah,
air
the
and the
answer's yes.
atmosphere? Really?
Between the water and the air will cause a temperature gradient, right? And that temperature gradient, which causes the refractive index gradient, which in turn would cause the bending of light. Now, to bend light, the amount you need it to bend, you would need a 70-degree temperature difference in 1 meter, which is unphysical and has never been seen on the fucking Earth.
Yeah, and I'm not
And you
saying
can
that
ignore
that's
the
what
first
it is.
meter above
But
sea
that's what it would
level.
have to be.
Oh my god.
Not what I'm saying it is.
But that's what it would have to
the
be to get
temperature-
this result.
As you've said, the temperature gradient changes per meter.
Yeah,
So-
great. Like 1
so you
degree, a
would
half
need
a degree.
Yeah, that's why I'm saying that you need something to measure the temperature across the entire track of the laser.
No,
because that
we
half a
don't.
degree, yes, because that half of a degree
No, you don't.
matters.
There goes line of sight for the military again.
Yeah.
So, hey, Grumman, check it out. If you were to shoot the laser and then you were to walk along it, you and me, we've set the laser up horizontal, and then we go down to 21.8 miles, and we're standing either side of the laser. Where's your refraction?
See the video that I sent?
He talked
Where's the
himself.
refraction?
In
You're standing next to the laser. Where's the refraction? You're not looking along it. You've walked along it to make sure that it's making its way, that there's nothing in the blocking its way. Where's the refraction when you get 21.8 miles down the other end?
You can see the fucking cannon looking at you. It's gonna kill you.
No, hold
Where's the
on.
refraction?
Oh, you
He's
can
got the
see
laser.
ship
We've
over the
set it up
horizon?
horizontal.
Crazy.
We've gone down the other end, 21.8 miles.
Horizon's not physical, dude.
Okay, so
Where's your
that's a
refraction?
claim.
Yeah, that's easy to prove. If the horizon was physical, could it move around?
Nope.
Does it move around?
Yes.
No.
Oh, no? You sure
No,
about
it
that?
doesn't.
The horizon
Whoa.
is dependent on the observer.
This dude just said the horizon don't move around. That's crazy, bro.
I heard that.
If the
That's going to be
observer
a good
moves,
one.
then the horizon moves.
Wow, dude.
Well, I mean, that sucks, dude, because we live on a ball of 315,000 mile radius.
Dude, the horizon doesn't rise to your eye level. That's
No one,
proven by
I said moved
aircraft.
No
around,
one
dude.
said it does. No one said it does.
Dude,
Only you
You
said
have like
it does.
2015 arguments, man.
In what way do you mean the horizon moves?
It'll appear at one distance one day and another distance the other day. In fact, it'll appear at different distances within hours.
During the same day, yeah. A couple different times.
Visibility.
So in the
Yeah, that's called
Dude.
refraction. That's
so it's not
something that we've
physical.
brought up. No,
So
it is.
you've just
It's
claimed,
the light from
you've
is
just
being
shot yourself
refracted
down,
differently.
Grumman. The horizon is not physical. It is now refracted. So you've just sold away any opportunity
if
you thought
get
you
high
had
enough
of
that
proving
refraction
Earth
isn't
curvature.
an issue, the horizon will not move.
The
based on
horizon is
distance.
non-existent if you beg for refraction, you knuckle dragger.
And
Yeah,
now
he's
you're
right.
contradicting NASA because NASA says the higher you get in altitude, the less defined the horizon becomes.
NASA's retarded
No,
and
the
a liar.
more defined the curve becomes.
Yeah, where'd you read about that?
Wow. He just says anything, doesn't he?
Dude, you're just a freaking...
Where did you read about that? No, dude, it's stuff that I've seen.
It's a published NASA
'cause
paper,
I've
by
been
the
in
way.
airplanes before.
Oh, did you
airplane.
see the curve of the Earth from an airplane? You can tell us that
That's
now?
what he said. He said, yeah. He said out the cockpit window, you can just see this big curve. And so that means we live on like a 500-mile radius Earth.
No,
Well, that's crazy because in the
that,
chat it's supposed to 315,000 mile radius Earth.
Yeah, I've never
No,
heard
that,
a
no, that
500.
curve is exactly what's expected to be seen if you run it through.
There's
a
no
proper
curve from an
curve
airplane.
calculation.
There's
Yes,
no
there
curve.
is.
No,
Yes,
there isn't.
Show us.
Yes, there is.
No, there
Post
isn't.
it.
Okay, so you disagree not only with geometry, but every other freaking person that's ever talked about it. Every other scientist, every other optical scientist, every other fucking person.
Who?
Hundreds
Like
of
who?
thousands of pilots.
You realize the Earth is supposed to have a diameter of 8,000 miles, and you're saying being 10 miles above it, you can see the curvature of the Earth. 10 miles above
Yes.
an 8,000 mile diameter ball.
Yes.
Think about what you're saying. You're 1/800th above the surface.
Yes.
Indio.
There are people
Isn't
that
the
can
radius
take.
3,900?
There are people.
There are
Indio.
If you had a
amateurs.
ball. Okay,
3,000
you're
people
fucking
have
cocked or
spoken.
something. You're just saying random shit, man. So, Grumman, if you had a ball that was 6 feet tall, an airplane would be 1/100th of an inch above it. Okay, you don't know what you're talking about. You're talking out your ass.
I've seen it from an aircraft.
No, you haven't.
So, yes, I
dude.
have.
Well, then you're a tiny earther, dude.
You're a liar, dude.
Yeah, you are a liar. Dude, not even 128,000 feet. Not even 250 miles, dude.
Felix Baumgartner said that he saw the curvature of the Earth.
Yeah,
so if you're
and
gonna pull that argument,
Neil deGrasse
And how are you going to
Tyson-
back that up?
in Neil deGrasse Tyson, right?
is wrong.
said he's wrong.
Yes.
Okay, so tell me, in the images he posted, right? The GoPro. So what is that? Planet Mexico?
No, that's a fish.
You can't even see the border of New Mexico. How can that be the horizon? How can that be the Earth?
Called a wide-angle lens.
Oh, so that's not the curve of the Earth. He didn't see the curve of the Earth from his fucking balloon,
Felix
bro.
Baumgartner did. With
No,
his
he
eyes.
didn't, dude. No, he didn't.
Oh, his eyes.
Hey, check it
he
out.
did.
He also saw the
Sorry,
curvature of the
guys.
Earth from ground level. Look inside, chat. 34 past the hour. Not even off the ground yet. That's him getting into the little shuttle thing.
Do you not understand the difference between human eyes and a camera?
Oh,
What's
he
that
doesn't
got to do
believe
with
his
your
eyes.
claim?
Was he looking for a visor?
And
The
sometimes
visor
people-
that distorts jack
some-
all because that's.
Oh, doesn't it? How do you know? Have you worn it? Have you worn it?
Yes, I have.
You know,
worn a
what about the
visor
shot
like
from
that.
inside the pod?
Holy
What about the
fuck.
shot from inside the pod? What about the shot from inside the pod?
Where you're looking through this tiny thing? Yeah, of course that's not gonna show fucking curvature.
So it doesn't look like it's curving. So it doesn't look like it's curving.
even defished images. People that have
Defished?
defished.
Is
yeah,
that
I
a
wouldn't
word?
answer that either, bro.
yeah, that's something that you can do.
So look in the chat. Which one of these circles of the circle the horizon for Felix Baumgartner? Which one?
Play the wider one.
Which of these circles? It's the fucking yellow one, dude. The yellow one. In the center. The yellow one is the complete, if you could see 360 degrees, his horizon. The biggest circle would be the ISS horizon. The ISS would only see 3% of the Earth. Now, you're trying to tell us that seeing 1,000th of the fucking Earth, you can see the curve. Get the fuck out of here, bro. 1,000th of the Earth, dude.
Why don't you
It's
ask
probably less
Felix
than 1,000.
Baumgartner yourself? Oh wait, you can't because he's fucking dead.
Yeah.
So what are you
well,
trying to push his claims for him then? Because he's fucking dead. Hello, McFly?
Anyway, I'm gonna send you a photo here.
I thought he wasn't dead. I thought we've determined he wasn't.
No, he died in a paraglider, I think, is what it was.
Maybe he told somebody, "Hey, I really think it was flat," and then they were like, "Shut up," and they killed him.
Gando, I sent you a couple of photos because I can't send images in this.
So if you could see the whole circle of the horizon, it would be 0.094% of the surface of the Earth. So that's a 10,000th, okay? And that's just assuming you could see the entire circle, which you can't because you only have a certain field of view, and your actual focal field of view, what you can actually focus on, is only 5% or 5 degrees. So he can see 1/100th of the surface of the Earth and see the curve. You're a retard, bro.
Here, I ran a photo through a Earth curve calculator. And that's the expected curvature at that height. And it matches with what the photo is showing.
You mean Bisman's Earth curve calculator? With the sliders? So you can just slide them around until it matches any image that you post?
If you know the refractive index, that's what you're getting. And that's also, first off,
if you know the
before you go stroking yourself over about the refractive index,
without refraction.
Yeah, Grumman, before you go stroking yourself about this refractive index, how about you...
The normal.
How about you supply us an image?
Refraction.
How about you shut up for 5 seconds and stop talking through people, you rude little turd. How about you, instead of stroking your ego about this refractive index, supply us with an image, right? And all I want is the known refractive index. I wouldn't do that again if I was that person. So how about supply us with an image that you know what the refractive index is, and then we'll run it through Bislin's little slider fun factory and see if it matches up.
Already supplied Indo with one.
It's Indio, not Indo.
Way, supplied him with one. If he wants to send it.
So you supplied the refractive index
yeah,
with
I
it.
see it. Hold on.
If he's laughing, this is going to be good.
Yeah.
Then there's horizon out at eye level at Rainier.
Yeah, but you got horizon at eye level at Baumgartner. How's that possible? And the horizon should never be at eye level unless your face is on the ground. The level of your eye.
I'm looking at photos here with a theodolite app that show in an airplane the horizon is not at eye level.
Planes fly tilted
We
up, you
know.
nitwit.
Out the side, they fly tilted, banked over?
Well, I don't know if it was banked in that instance.
Well, because the photo that I'm looking at is out the side window.
Yeah, that's fantastic.
So if you want to try the excuse of it's tilted, you would.
It is tilted.
banked
Go get the
over.
negative degrees, dude.
Oh, man.
You know how one of
They're
this freaking thing works? Do you know how a
They're
plane works?
They're pitched up. Pitch and roll are different. They're pitched.
Yeah, I know. It's -3 degrees on one side and -0.3 degrees on one side and -0.5 on the other. Do you see it? Think you measure the fucking dude? You gotta be some kind of idiot, dude. You really honestly have to be freaking an idiot. These is 2017 lameness, dude. So there's your image. You know this one that says -0.3? That means the phone is tilted.
Yeah, and so -0.3 degrees is barely tilt.
And the first, but it is tilted.
Now he's going to make excuses for how little it's tilted. So it's tilted. You agree with that? Excellent.
First of all, the expectate, that doesn't even look like a real fucking photograph, first of all. And that just looks like a shit overlay. This isn't a photograph. Did this come from a video?
No, it didn't.
Where did it come from?
Me.
And why would you expect Mount Rainier,
Mount Hood,
whatever? Why would you expect that? You know he's tilted up, right?
By 0.03 degrees.
Yeah, but he's 5,000. He's at 5,000 feet, and if Mount Hood is higher than he is, he's gonna have to be tilted back. He should have to be tilting down. Because I don't know how far away he is, right? Because
yeah, what's the distance?
How far away is
to the mountain from that observation?
Well, we can calculate how much he's supposed to be tilted down, because he should be tilted down, but he's tilted up. See how the crosshair is centered on the peak of the mountain? So that peak should be 5,000 feet higher than where he is.
Yeah, and then you take into account distance.
If the Earth was flat.
Take into account distance.
Yeah, then there's a drop. If we only knew the distance. What is the distance? Any clue? And where did he get his altitude from?
GPS altimeters exist. They're
Oh my
used with
God.
mountaineering. Something I use when I go hiking.
Okay, he's inside of an airplane, isn't he? Pressurized cabin?
That doesn't look like he's inside of an airplane.
Well, I don't know what this is. It's impossible to evaluate. To be honest. The image looks like it was color corrected, and this looks fucking overlaid. This don't even look right. I don't know if he's in an airplane, but he can't use a GPS altimeter. You know that the GPS's vertical values are the worst known. They can be off by hundreds of meters.
In my experience, they haven't been, because I use them when I go hiking.
Anecdotal evidence isn't.
It's not anecdotal. It's personal.
It is anecdotal. You said,
no,
in my
not.
experience. As soon as you said that, that makes it anecdotal.
No, it doesn't. It makes it personal experience.
Yeah, anecdotal. Do you not know what that word means?
Not anecdotal. I'm muting this guy. These are apps that you can download on your phone. They're theodolite apps.
Don't mute Indio or you'll be banned.
Not muting Indio. I'm muting the guy.
Anecdotal, not necessarily true or reliable, because based on personal accounts.
If you mute anybody, you're gonna get kicked.
Well, I don't know about that. I'm gonna unmute you, Iron Bear, dude. Try not to have verbal fucking diarrhea.
I was never trying to diarrhea anybody.
Just he played this game.
You're just like you're not following the conversation. You're just interjecting random shit, dude. Try to follow along. What's up, Casey?
How you doing, you alright?
So haven't you noticed, Grumman, that you haven't presented any measurements of the surface of the Earth?
That photo that is a measurement of
the
surface of the Earth.
Well, how far? No, it doesn't. If we don't know how far away the goddamn mountain is. See, if we know how far away the mountain is, and we knew his elevation, we could calculate how much he's supposed to dip down because of the curve of the Earth. For some reason, he's tilted up. So if you look at the right-hand side, that's his tilt, okay? And he's tilted up.
Negative is down.
Oh yeah, he's tilted down. So half a degree.
Half a degree over 30 miles is a long way.
Half a degree would be 0.5. That's 0.05.
Over 30 miles?
So, according to calculations, thanks to ChatGPT, because I'm too lazy to do any of them.
Hey, Hellcat.
Roughly 83
Why are you on
miles.
here spewing the same stuff that you've been spewing on spaces?
Calculations. Thanks to ChatGPT, because I'm too late. Also, I love that Platter posted that that photo. I'd love to see a fighter jet go Mach 2 at sea level without ripping its wings off.
Like at sea level, like on the sea level, or like 10 meters above? Or
how much do you think the air pressure changes?
To be a boat? You want it to hit the water at sea level?
Photo that he's showing, it's basically skimming the waves.
Are you trying to say that that photo is fake?
No, I'm saying that the premise of at Mach 2 is incorrect. At most, it's going transonic, which is what that cone is. That's a transonic cone.
Supersonic.
No, that's transonic.
So, can you explain to me, because I'm stupid, the difference between transonic and supersonic, real quick?
Transonic is between subsonic and supersonic. It's basically commercial airliners fly at speeds that are in the transonic zone.
So, like, right at that speed that's not quite supersonic, but above sonic? Like, what are you talking about? You sound dumb.
Like 500 to 600 miles an hour.
Yeah, 500 to 600 miles an hour.
Yeah, speed of sound is what, like 780?
Yeah, it's a range called transonic. It doesn't mean that you're above the speed of sound.
Made up shit.
Sonic and supersonic are also completely made up things, as is the speed of sound.
Stupid marketing words, dude, that they made up was that they were developing airplanes. We got a transonic airplane. Well, I got a supersonic airplane. I got a hypersonic airplane. I'm even better.
Well,
dude, I got a thermometer. I got a thermometer that measures 0 degrees, but it calls it trans zero. It's not below 0 or above 0. It's trans 0.
I'm trans 0.
It's transonic.
I got a
in between
trans PSI pressure gauge, man.
Oh yeah.
How are you talking anything if you're still not?
Can you say something interesting so we don't have to listen to buzzwords?
This is
made up bullshit.
This is aerodynamic. This is basic airplane stuff.
Yeah, basic airplane stuff.
Typically between Mach 0.8 and 1.2, or transonic flow, is seen.
Oh, I get it. You're trying to say that a plane can fly subsonic and supersonic, so it can transition between supersonic and subsonic flight? Is that what you're saying?
Transonic is that transition.
Oh, okay, cool story. How is this relevant to anything we're talking about?
Not.
All right, thanks. Then quit picking at it. Yeah, I want to actually hear a conversation that progresses somewhere.
Any plane that can fly supersonic speeds can also fly at subsonic speeds.
Holy fuck! Get muted, dude. Yeah. How about that?
Fucking warned him, dude. Were you in here when I just warned him? I just unmuted him.
Yeah.
Yeah.
Fuck, dude. Dude's on his own shit, man. Dude, go start a guest room. Trans units. You might get a different crowd than what you're expecting, but
based off his picture with his coordinates at the top of it, your mountain from where that was taken, you're looking at 83.32 miles.
All right.
Yeah, buddy. Let's say the horizon is below, like perfect level line from the midline of your vision. Let's say that's true. Whoopie frick. The ground is below you. It's supposed to be below you. What's the problem? Now let me put this in a logic form so you can understand. All right. The ground below you is below you. Therefore, it's below you. Follow that? Very simple.
I can barely understand you with the roboting.
Oh, my bad.
You're not roboting, you're just crackling, your mic's a little fucking broken up or something.
Oh, man.
I thought we call that roboting when the mic is...
Roboting is when you have a bad internet connection and the packets don't arrive in sequence. He just has a freaking... I think your Bluetooth is dying.
Man. All right. I give up.
The X-Sound sound good then. Maybe you're
Yeah,
just
you
too far
sound
away
good
from your
then.
device.
All right, that's it.
And
I'm
now
back.
it's
Oh man.
dude, I heard a hint of crackle. And sorry, my ears are sensitive to stuff like that. I did orchestra for like 4
That's
years.
great, dude. All I need to know is if I'm wasting my time talking.
I wouldn't say you're wasting your time, but you might want to get
Am
a
I
new microphone.
Am I trans crackle?
Yeah, you're
Jumping
crackling on some things, and then you're
transitioning to no crackle.
yeah.
All right. I'll say this one more time, dude. The horizon is where the sky appears to meet the ground. The ground is below you, in case you didn't know that. So, at all times, the horizon's below you. I mean, I don't understand what the problem is. Like, is there a problem with the horizon being low in your field of view? Is that an issue?
I mean, there's a claim that's made by a lot of flat earthers that is that the horizon always rises to your eye level.
What does that mean?
It means that you're going to see the horizon in the same place in your vision, like directly
Really?
in the center.
You sure?
In the center of your vision.
Whoa, bro. Rises to and in the center of don't jive. So, for example, if I say I'm going to the store, I've not yet arrived at the store. If I say I'm in the center of the store, I'm in the store. So maybe it's a language problem. Just because flat earthers say that the horizon should be at the midline of your vision, if anybody has, they're wrong. So why would it matter to show people who aren't the people making that claim that the horizon is below the midline of your vision? Like, what's the issue? What's the problem?
Because that's something that we expect on a sphere.
Dude, okay, let me help you out, friend. The ground is below you, no matter what, right?
Yeah.
We all agree, right? It's not like when you go up high in the sky, the ground gets taller, right? So I don't know what aspersions you've been cast by some moronic flat earther that may or may not have told you the horizon should be at the midline of your vision if the earth was flat, but that's stupid.
The point is the horizon drops away from you as you get higher.
Yeah, no duh, dude. The ground is below you. The higher you go, the more it's below you. Holy moly, bro. Duh.
So there's something physical about the horizon.
Holy crap, one more time for the slow kids in the back. The horizon is where the surface of the earth appears to meet the sky. So yeah, there's some part of it that's the ground, and the ground is below you all the time. Unless you're at the base of a mountain, I guess. But if you get higher, then it's going to get lower. What's the issue?
So the horizon is a physical thing.
Holy crap, dude. Painful.
It's been this way for like an hour.
Dude, the horizon's an artifact of the fact that you see everything by acquiring light from the outside world. That's all it is, dude. Because you don't have a supercomputer plugged into the matrix so you can see all floating points simultaneously in an orthographic and transdimensional representation, dude. Yeah, you have eyes, you have to see. You have an angular field of view. So maybe you're under the misapprehension that if ideal artist perspective existed in reality, which it doesn't, that everything would, if the earth was flat, go into infinity to a point. Well, that's not even possible, dude. Because in reality, you actually have to use light to see, not ideal lines that you draw on a piece of paper. And light actually has properties. It takes up space, it has wavelengths, right? There's angles involved. There's near field diffraction, far field diffraction. There's all kinds of things going on. There's no such thing as ideal perspective in the real world. Kind of like there's no such thing as platonic shapes. I mean, this would be as stupid as me saying the Earth can't be a globe because it's not a perfect sphere. Would you take me seriously if I said something like that? The answer is no, you wouldn't. Because I'd be arguing from an ideal, which is nonsense. I mean, if you want to say the Earth can't be flat because it's not an ideal form represented in artist perspective, I mean, I don't know what to do here.
Not what I was saying, but okay.
Well, then why does the horizon being lower at the higher you go have any merit to talking about the Earth being a globe or flat then? As if the
Because
horizon has
it
to be
is
at the
a
midline of
claim
your
that
vision.
has been made that it rises to
Okay.
eye level.
Okay, fair. Okay, so it's a bunk claim. It's a stupid claim. Do we both agree? Yeah, we both agree.
Yes.
Okay, perfect. So now that we know it doesn't prove the Earth's not flat, whoop-de-doo.
Then the photo that does show the Earth curving was just dismissed as, oh, that's fake.
What Earth curving? That photo that you showed where the horizon was lower than the crosshairs that you put.
No, not that one.
Okay, then where's the one we're showing it's curving?
One that had, what's his name, Bislin's calculator overlaid.
What? That's
I can
wait a
send
minute,
you
dude. Are you basically go ahead? But are you basically having an image where you can't see the bottom of it, and then you're doing like a blink test, or this bottom is sunk under a horizon line, and you think that because you can't see the bottom that you're looking at curvature? That's not showing curvature.
No, it's
dude.
because you can see it from side to side.
Side to side. Oh, all right. Yeah, post that.
How much curve are you claiming to see from side to side? Do you have a number?
Not very much.
So it's just like it looks curved, it must be curved, but with no data to go with it.
Yeah, it's a 3-degree dip angle.
I'm pretty sure this is going to be bogus nothing. What? Dude, you just sent me the same image you were talking about earlier.
No, the image that I was talking about earlier was this one.
All right, you must have done it accidentally.
Oh, that's
no,
the
you
same
posted
way.
the same thing.
I just posted the same thing. No, that's not what I meant. I forgot to copy the correct image. That's
no worries.
That's the photo.
Holy crap, dude! That's not a photo. Are you telling me this is an overlay on an actual photo?
Yeah, the second one that I posted is an overlay. The first one is a photo taken with an app that does the overlay.
Holy crap. One X iPhone camera? Holy crap. You think an iPhone doesn't have barrel distortion because you just put on fisheye?
What barrel does an iPhone camera have?
Dude. All it says is 1X iPhone camera. What does that mean? The first iPhone?
No, it means that it's not zoomed in or distorted or anything.
Yeah, which phone? Which iPhone?
I don't know.
Well, then who cares? You can't even go to the particulars of the lens.
Well, it's an iPhone camera. There's
Okay, how about I post my picture from the side of a plane showing the wing and an upward curved horizon. So I have a picture of an upward curved horizon. You have a picture of a downward curved horizon. Who's correct?
I also have a photo of a downward curved horizon of my own. Let me see.
Hey, Grumman,
I
are
think
these
it's on my
pictures these
thing.
pictures you're posting gonna be authentic?
Something that I've used before, and then people are always like, "Why is the wing curving up and stuff?" And it's like, I mean, that's how that airplane is designed.
Oh yeah.
Really interesting, like the 777 or 787.
know, dude. There's no way to even validate this is even a photo, dude. So I don't even know what you're doing here. But whatever. I will save it. Let me save it here. $43,000 feet. Okay. Oh, at 43,000 feet, the distance to the horizon is a certain distance, right? Whatever it is, correct? Let's just call it one horizon distance. Okay, makes sense? Now, if you're on a ball and the horizon's a curve, then that means the horizon is the same distance 360 degrees around you, correct? Not only that, but it's the same angle. From your altitude down, it's the same angle, 360 degrees around. So it's the same angle and the same distance. So where's the curvature information coming from to be rendered in the image? Think about it. In order for that curved line in your image to be the curve of the Earth, then the left and right have to be either a further distance or a shorter distance, or a bigger angle or a lesser angle. So that would mean that what you're looking at is changing distances and changing angles. How's that happening if the Earth's a ball? You know what's interesting about a flat thing is that to the corners is a diagonal distance that's greater than the center distance. You can't get that on a sphere, dude. So we got a problem here. So my question is, in your image, the curve is higher in the center and it's down in the left and the right. So which portion is longer? Like which way? When you look left, is the Earth longer, or when you look right, is the Earth longer, or when you look straight ahead, is the Earth longer? Which one?
I would say left or right.
Why? Well, let me ask you this question. It's to ask of a glober, because the glober is claiming that this arc represents you're on a sphere, but it's the same distance and it's the same drop angle. So that curve is the same distance and the same drop angle. And if the z-axis in the distance and the y-axis up and down is compounded on the same axis in a two-dimensional image, which it is, then what's going on? How are you getting a curve at all? Wouldn't it have to be more of an angle to the left and to the right?
Wouldn't images on the left side also be tilted away from the images on the right side if that was Earth curve?
Well, we still got a problem that it's the same drop angle. Same drop angle, same distance. So if you're looking straight ahead and a same drop angle and the same distance causes the quote unquote alleged curve of the Earth to be rendered high in the image, then why is it not causing the quote-unquote curve of the Earth to being rendered in the same height on the left and the right?
Why?
What's that?
I said, I'm asking why. What's the answer?
Oh, because it's optical curve, not physical curve. That's why.
That's what I was gonna say. I knew it. I knew it. Damn fisheye lens. I bet the CIA invented the fisheye lens too.
But if you're above the Earth and the horizon is a circle, okay, that circle, the bounds of that circle is the same distance, same radius all the way around you, and the same drop angle. So if a portion of it's coming in at you and it renders at a certain height in your field of view, then the rest should as well, because it's the same. So pick any point on that line. Just look at the image he posted. Well, wait a minute. Did you guys see the image he posted? Let me post it.
Yeah, we saw it.
This one,
a little
and he
while
posted
back.
this one here.
Yeah, we saw those. The second
Okay,
one is.
so put your finger on any point on that apparent curved line that he's claiming is a curved line. Pick any point.
Mm-hmm.
Put your finger there. Once you got it locked in, tell me what the distance and the drop angle is. Someone already posted the distance. We'll just use 3 degrees for the drop angle. So -3 for the drop angle at 13,000 meters. Okay, you got it? 13,000 meters, 3 degrees drop. Now pick a different point. It's the same, 13,000, 3 degrees drop. Okay, so if you picked a different spot, why is it not rendered in the same position if the values from the one rendered it at a certain point in your field of view? Why are the rest of them not rendered the same? Because all the light's coming in from those points at the same distance and the same angles. You know, there's a thing out there that people think there's distortion-free lenses, and that's not true. Lenses just manage the distortions in different ways. So they preserve one quality at the expense of another, like rectilinear lenses. People say, oh, rectilinear lenses are distortion-free. Well, that's not true. In fact, if you go to an actual camera website, an actual photography website, you know, not somebody's blog or some Wikipedia article, they'll actually explain it to you. Funny enough, the way that the rectilinear lens works on preserving the distortion, if you had a dark, let's just say a green bottom half of a page and a red top half of the page, in the far field, the further you get away from the origin, from the center of the image, the red and the green would separate because the values increase on the y-axis as you get further away from zero. So if you actually did that and looked at it again, it would look like a curve. Kind of weird like that. So in other words, the far left and far right side of the image would look curved. And since that's how they work, and we know that, then you would expect something that's a straight line to look curved. So funnily enough, and this is weird, the globers at this altitude should expect to see a flat horizon, and they should expect that the lens is what's causing the apparent curvature. even if the Earth was a globe. You got to get a lot further away from the surface for those angular relationships to change to where you're going to have discernible curvature information. Well, it's too bad Grumman boy didn't stick around to tell me how he's getting curvature information from the same angle and the same distance, no matter which way you look. All right, friends, go back to that image where you put your finger. Now, if you spin your head, what's happening over on the left is all of a sudden going to be in the center of the vision. It's going to be high in the frame again. What caused what's on the left to come up high in the frame? If it already was at the same drop angle and the same distance, what changed? Very interesting, huh? What's funny, dude, is that a Glover said that even the ISS shouldn't see curve. He was actually a planetarium director.